Okay, so now we are moving to the bonding in case of triatomic molecules. So this is towards the so when we think of more than two atoms, और when we talk about polyatomic molecules, so two के बाद three आता है number, so three atoms together. So the first case that this we will try to understand with an example, and the first example that we are going to discuss is BeH2, and so BeH2 has been found to be linear. So there are certain experimental evidences based on which we start our explanation, and how the bonds could have been formed, how the orbitals could have been mixed. So first thing when we so it is known through experiments, it is known to be linear hydrogen. So we are labeling the two hydrogens as hydrogen A, hydrogen B for clarity of understanding, because the orbitals that we will take, we will accordingly label them, and then so this is first thing that we do. We label the 1s orbitals on the hydrogen atoms as A and B. Then we have 2s orbitals and 2p orbitals on the beryllium. So if you are considering the internuclear axis, there's only one p orbital which will be lying along the internuclear axis. Other two will be perpendicular, right? So when we for the this combination that we are going to work out, only pz orbitals are important, because so the two, because you do not have any other counterpart on hydrogen to overlap with the other px and py orbitals. ठीक है? So you have 2s orbitals and 2pz on beryllium that will take part. The other two have no doesn't have suitable symmetry to overlap with the 2s or 1s orbital on hydrogen. ठीक है? So, so only so the two orbitals that we are talking about here is that px and py. They do not participate in this. They are not there because they are perpendicular to the internuclear axis. Uh, Hydrogen has only in the ground state you have electrons only in the 1s orbital, and so there is no overlap happening for the px and py orbitals. Only the pz is counted. So, so we again, so the basic scheme of working out the combination is same LCA, which we have been doing for all the combination of atomic orbitals. So, but here you have a problem that when you have more than two atoms, how will you consider? मतलब आप एमो डायग्राम में ए और बी करके हमने बनाया ड्रॉ किया, when you have 1 2 3, then where will you put when you make starting your orbitals? So in such cases what we do, we first make groupings. We based on symmetry we identify the orbitals of different atoms and make group orbitals. So we will the approach will be similar to what we have been doing, like S or S combination, S and P combinations like that. So so how do we do the groupings? This A and B, the hydrogens, the two hydrogen atom here, they are going to be make two group orbitals out of the constructive and destructive interference. So the two group orbitals will be labeled as G1 and G2. G1 and G2. These are due to the constructive interference, and this one due to the destructive interference. So we will first combine these things. HA, the orbital, 1s orbitals of the two due to the destructive interference, So we'll start doing this, and because yeah. So how do we do this? Group one, in phase combination of 1s orbitals. So when we write it as, so psi for Hs, wave function for the Hb hydrogen atoms. This will be, this have right kind of symmetry to overlap with 2s orbital on beryllium. We will just see the pictures. Group 2 orbitals will be out of phase combination of 1s orbitals. So sigma Ha minus Hb. So just please reverse the sign and you get. So these two sets of orbitals, when they are formed, they have a right kind of symmetry. This has the right kind of symmetry to overlap with the 2s orbital on beryllium. This is the right kind of symmetry to overlap with the 2pz orbital on beryllium. So because this is out of phase combination, this will be lying higher in energy. G1, which is in phase combination, will be lying lower in energy. अब आपका रास्ता clear हो गया. Now you have got the idea how I am going to make MO diagram. We will place G1 lower in energy, G2 slightly lower on one side, grouping करके. और इस तरफ beryllium रहेगा एक side, left hand side में. You can construct your MO diagram. So this is the basic idea that in any case, whenever you have more than two atoms, you will be doing. Okay. Uh, yeah. So the combinations are similar to what you have been doing for H2 molecule. जैसे H2 molecule में combination होता था, वैसा ही हम कर रहे हैं G1 G2 में भी. This is the combination that we have. Only that these atoms are now away farther. They are farther from each other. They are not so close as in H2 atom. But उसी तरह से थोड़ा, अब यहाँ पे एक सवाल आता है, आप पूछ सकते हैं कि they are so far apart, how will there will be an overlap? How can we justify this kind of scheme? That's that would be a genuine question. कि हाँ ये तो अब जब पास आए तब तो ओवरलैप दिखा रहे थे, लेकिन अब तो दूर दूर है, और तब भी आप पहले इनको कंबाइन करके कह रहे हो कि आप यहाँ पे G1 और G2 कॉम्बिनेशन हो रहा है. तो इस now this part is important कि you are drawing this circle, है ना, छोटा सर्कल बड़ा 1:2, that represents only the area where you have maximum amplitude of the wave, or you can say the around 80 to 90% electron density. Where is the rest of the 10%? It is immediately after that circle was zero नहीं हो रहा. It is not going to be electron density is not zero next to that circle boundary. So you do not have such and what we have seen in the hydrogen H2 का case जब हम radial wave function देख रहे थे, you remember uh, when we have seen that the radial part of the wave function psi radial, it was decaying like this, है ना? So it was the radius r. So in this segment, so you are drawing circle, यहाँ पे आप ऐसे draw करके दिखा रहे हो, लेकिन यहाँ पे एक substantial 90% electron density you are showing, but rest of the here it has some there is some amplitude of the wave. It is not, the amplitude of the wave is not zero here beyond this point where you have the most probable radius, and amplitude of the wave only goes to zero at infinity. Only at infinity the amplitude of the wave is going to zero. So everywhere else it has some amplitude. So if there is another s orbital, they will have some interaction will be there. Interaction नहीं होगा ये कहना गलत. Interaction होगा, feeble होगा, बहुत कम होगा. It will be feeble. It will be very to a very less extent. That's true. But there will be and so based on that we are justifying our this drawing the combinations. because it is not a 90% area वाला जो इलेक्ट्रॉन डेंसिटी वो ओवरलैप कर रहा है, ऐसा नहीं है. The rest 10% which is having spread over up to infinity, है ना. तो उस पार्ट में भी कुछ there is electron wave, there is amplitude of the wave, and so we can say that there will be a very little amount of overlap, but there will be uh, this kind of interaction is possible. And so this drawing that we are showing here is okay, it is justified. ठीक है, we are not saying that. देखिए यहाँ पे लास्ट सेंटेंस में हमने कहा कि इट इज सिमिलर टू व्हाट वी हैव बीन प्रीवियसली वी हैव बीन डूइंग विद डाई हाइड्रोजन. दो हाइड्रोजन को जैसे कंबाइन करते वही. द डिफरेंस हियर इज दैट that when we are doing this, there is the overlap is to a much lesser extent because the atoms are now two hydrogen atoms which we are considering are much farther apart. ठीक है, but they are not infinite distance apart. So there is and as we have seen from the previous uh, discussion, that the electron amplitude of the 1s electron goes to zero only at infinity. Everywhere else it has some finite value, and that means that if two hydrogen atoms of 1s atom, even if they are separated by a certain distance, as in this case, there will be some small overlap will be there. And so अगर ओवरलैप कम होगा तो सेपरेशन बिटवीन टू ऑर्बिटल्स भी कम होगा. तो ये हमारे एनर्जी डायग्राम में भी जाना चाहिए कि पहले H2 के मॉलिक्यूल के केस में जितना अच्छा ओवरलैप हो रहा था, तो सेपरेशन जो सिग्मा और सिग्मा स्टार बन रहा था, सेपरेशन ज़्यादा दिखा रहा था. Now we will draw it much closer to each other when we draw G1 G2. ठीक है, तो ये सब very fine points, these are the finer points that you need to थोड़ा सोचना होगा. एक बार में ना समझ में आए, दो तीन बार और करेंगे. So this is the basic idea. The colors are conveying the sign of wave function. So when you have a G1 orbital, that means you have plus sign of this, plus sign of the wave function. This is plus sign of this is the minus sign of. So this is the sign of the wave function. So these are the sign of psi wave function. This, ठीक है, the two colors convey this idea. And so the combinations when we work out. So when you are looking at this orbital, so this is one group orbital which is here having two. अब आप इसके साथ combine s orbital of beryllium. Look, visualize the 2s orbital of beryllium. It has the right kind of symmetry to overlap with this G1 side. अब ये G1 उठा के बस यहाँ पे डाल दीजिए बेरिलियम के ऑर्बिटल. You will get a good interaction between the two. So similarly, if you are looking at G2 orbital, it has right kind of symmetry. So इसमें क्या है, एक तरफ blue है, एक तरफ red है, plus है तो दूसरी तरफ minus sign of the wave function. So p orbital में क्या होता है, it is the p orbital, pz orbital of the so this is the pz orbital of the beryllium, and it has the similar features. On one side it has negative sign of the wave function. On the right hand side it has a positive sign of the wave function. So they can have they are appropriate combinations. ठीक है, इस तरह से हम कॉम्बिनेशन फाइंड आउट करते हैं कि कौन सा किसके साथ मैच करता हुआ लग रहा है, which one will go along with what. So G1 combines with 2s on beryllium in phase combination and out of phase combination, both you can work out. So and in a simple case you can so this combination that you have, you will write for this sigma psi 2s plus G1. ये जो पूरा है ये आपका G1 था. So G1, and of course you give this A and B, the coefficient to indicate how much they are contributing to each of in the formation of that orbital. So that is your one set. The second out of phase combination, that will be anti-bonding. You just put the minus sign over here. So this, just we have put the minus sign, we are reversing the sign of G1 orbital. मतलब ये दोनों प्लस प्लस थे, अब दोनों माइनस माइनस हो गए. ठीक है. So then we expand it again. So this was the combination of Ha plus Hp. We expand it here as well. Write it like this. So yeah. So G1. Now in a similar fashion, you can think of combining the G2 orbitals, G2 ligand, sorry, not ligand, group orbitals. Combine the 2pz on beryllium. The one that we have just seen over here. And out, this is a combination. So now psi 2p psi g2, the wave function for g2, the wave function for 2p. And then in a similar fashion, you can write for the out of phase combination. You put the minus sign over, you put the minus sign here. आप नोट कर रहे हैं एक और चीज जो मैंने पहले भी कहा था, सी और डी और सी, वहां पे ए बी था, बी ए हो गया था, किया था कि नहीं मैंने मैंने हाँ, you noted this, a b b a, ये ऑब्वियस है ना, एक तरफ इसका ए का ज्यादा है तो बी का ज्यादा होगा, तो कोफिशिएंट जस्ट इंटरचेंज हो जाएगा, स्वैपिंग ऑफ द टू स्टैटिस्टिकल कोफिशिएंट्स which take into account the relative contribution. ठीक है. So you are just, था ना, ए और बी जब अनइक्वल होगा, अगर ये 70% इसमें कंट्रीब्यूट कर रहा है तो इसका 30% इधर जा रहा है, इसका 70% इसमें जा रहा है, तो द कोफिशिएंट इस 70% के लिए जो अगर ए था तो वो अब इसके साथ आएगा. So it will go like this. So out of phase combination, so we were writing this. So again, once you write this, expand the expression for G2, which you have already done initially, HA minus HB, है ना, और overall with again with the minus sign, HA minus HB. जो पहले हमने सबसे पहले किया ग्रुप ऑर्बिटल्स, उसी को बस एक्सपेंड किया है वो यहाँ पे लिख के. ठीक है. सो ए बी सी डी आर द statistical coefficient, weighting coefficients, so which is to take into account the electronegativity and all. वही वही है, इलेक्ट्रोनेगेटिविटी की वजह से ही आ रहा है, but basically it is better to say what the way you understand, that they give you an idea of the relative contribution each one is making in making of that particular orbital, and which of course the relative contribution is different because of the electronegativity. So when you think of the overall picture, this is how it builds up. ठीक है. So you have this, or rather we should write here, this is lower one is G1 and this one is G2, G1 G2 combination जो हमने दिखा है, very small separation, not very big, because we understand the overlap is not very good, they are away from each other, so there is a very small faint overlap, and so group orbitals when we are making it, they will be having like this. Now first combination, when you are having all of them together, so S2s orbital, और यहाँ पे 1s all in phase, plus 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 sign, so this is the kind of orbital. So this is the sigma 1 orbital that is formed, pictorially representing the same thing, another with a combination of G2. So this is due to the combination of 2s बेरिलियम का 2s कंबाइन कर रहा है और विथ G1, जो अभी हमने वहाँ देखा हियर, इसका 2p with 2pz with, sorry, combining with G2। तो ये आपका एक हो गया। और जस्ट इसके ऊपर देखिए तो उसका एंटी बॉन्डिंग कॉम्बिनेशन है। सो सिग्मा वन स्टार, तो एंटी बॉन्डिंग कॉम्बिनेशन यू आर राइटिंग -G1 means HASB both were positive initially, now both are negative sign, so the blue color represents that, ब्लू कलर जो वहाँ देख रहे हैं, ठीक है। अभी आपने हमने देखा ना, ये कॉम्बिनेशन हमने पहले कंसिडर किया when we are writing minus, just a moment, जैसे ये सारा कंबाइन करेंगे तो एक ऑर्बिटल बनेगा, है ना, कंबाइन करके in phase combination the electron cloud will be symmetrically distributed around it. So this is one combination that you saw. Now so this was when you are writing plus G1. When you are writing minus G1 means this, if this was plus this will become minus, मतलब माइनस साइन ऑफ वेव फंक्शन, तो ब्लू कलर में आप उसका दिखा रहे हैं। अब आप उसी को देखिए, ब्लू कलर उसको कर देना है, तो दैट इज व्हाट इज हैपनिंग हियर। यू सी, ये जो ब्लू है, ये दोनों वहाँ पे जो दो ये रेड ड्रॉ होता वो ब्लू हो गया, एंड सो इट इज आउट ऑफ द फेज कॉम्बिनेशन, द 2s का तो वही है, सो आउट ऑफ फेज कॉम्बिनेशन हियर एंड सो यू हैव नोड, 2 nodes are created. In a similar fashion, you consider the other one. You were writing minus G2, so एक प्लस था इधर, एक माइनस साइन था हाइड्रोजन का, अब उलट जाएगा माइनस प्लस। सो अब देखो, इधर जो रेड था वो ब्लू हो गया, इधर जो ब्लू था वो अब रेड हो गया, और अब बेरिलियम का जो पी ऑर्बिटल था उसको अनडिस्टर्ब वैसा ही रहने दो, because the mathematics that you have been following, you are writing that way, है ना, 2s minus G1, 2p minus G1 G2, ये माइनस G2 वाला पार्ट को रिप्रेजेंट कर रहा है। नाउ यू हैव 1 2 3 nodes, so number of nodes increases, so this is the way these orbitals antibonding the other two orbitals of p on beryllium, px py, they remain, there is no counterpart on hydrogen to interact with them, so their energy remains unchanged. These are non-bonding orbitals, so these are non-bonding, ठीक है। triatomic BeS2, these are the pictures that you can draw. This is the in James E. Hui, this is from the book. ठीक है, उसमें ये डायग्राम दिया हुआ है, तो so this is how you can make when you are writing an exam, because then you will won't be able to have so many colors to use, है ना, तब आपको पेन एंड पेपर पे ड्रॉ करना होगा, तो ऐसे करेंगे प्लस एंड साइन, so this combination, this is the second, and then you have this combination for, right, all the 4 combinations. So plus minus, now you understand here, this is plus, for throughout this thing it is plus plus combination, so same sign of wave function there is, so this is, these are bonding combinations, and then so similar to this, ये हाइड्रोजन का यहाँ पे देख रहे हैं दोनों माइनस, साइन ऑफ द वेव फंक्शन हैज बीन इंटरचेंज, सो G1 G2 जो कहा हमने वो सब यहाँ पे आपका दिख रहा है, दिस इज G1 This is your G2, and then you can work out the details. Okay, so this is so many diagrams can be drawn. So this is the combination 2s, 1s in phase, 2p, 1s out of phase. So this is also in phase. Then इसी का वही चीज है, लेकिन बस हमने चेंज कर दिया, ये जो दोनों सर्कल देख रहे थे इसका साइन चेंज कर दिया, आउट ऑफ फेस कॉम्बिनेशन. अगेन यूएस इसका आउट ऑफ फेस. सो यू आर हैविंग दिस, सो जहाँ पे, so this is again out of phase. यही किया है पूरे सब 3-4 डिफरेंट वेज जो हमने दिखा, सब एक ही चीज को रिप्रेजेंट कर रहे हैं. ठीक है, सो दिस इज व्हाट वी आर ट्राइंग टू कन्वे in all these pictures. Out of phase combinations of orbitals, in phase combinations, and the two orbitals जो px और py है, they are indifferent, कुछ हो ही नहीं रहा है, उनके कोई काउंटर पार्ट ही नहीं है हाइड्रोजन के. So these were the reasons. So A, B, C, D rating coefficient due to the that we have included. So they represent the differing contributions of atomic orbitals in each of which goes into the making of the formation of bonding and anti-bonding elements. So in case of all these molecular orbitals, the electron cloud is throughout delocalized over 3 atoms. So this is what you get automatically in molecular orbital, which was not there in valence bond theory. ठीक है, कि जैसे हमने पहला molecular orbital बनाया, electron is automatically getting delocalized. Sorry, this means that electron is delocalized over this entire three. There are 3 nuclei, and सबके it is all around it. The electrons are there in this orbital. The first one that we are considering, and in a similar way there is distribution. So delocalization automatically comes in the molecular orbital treatment when you try to make it is a very general kind of result for when you have atoms greater than 2. ठीक है, so 1s orbitals on beryllium, okay, there's one more point. Why we have not considered 1s orbitals for in this interaction? Because again, जैसे हमने H and F का एग्जाम्पल लिया था, if although the fluorine 2s orbital has good symmetry, the energy difference was huge, and that's why overlap was poor. We didn't for the similar reason we do not take 1s orbital on beryllium in this consideration. ठीक है, so the energy difference because on 1s on beryllium and energy of 1s hydrogen atoms are very same. So that remains 1s on 1s as non-bonding orbital. So that also remains as a, so 1s orbital which is there in beryllium also remains as a non-bonding. Important point. हमने सिर्फ 2s2p का किया, लेकिन एक वो भी है जो इसका कोई काउंटर पार्ट नहीं निकला. px py का वो भी नॉन बॉन्डिंग था. 1s वाला भी जो बेरिलियम में जो 1s है, दैट इज आल्सो नॉन बॉन्डिंग. This we'll discuss next class. And this is required to explain water H2O. ठीक है, अभी के लिए इतना ही.